Hey, sixth graders, we are on lesson 1.3 and we are going to be doing an investigation today. So we are going to hopefully better understand the process of energy transfer, and we are also going to be able to communicate that process of energy transfer through some written and spoken examples. So we already talked about New Zealand and whether it's going to have more or less energy during an El Nino year. So temperature is the measure of how hot or how cold something is, or we can talk about temperature as the amount of energy in something. So we know that air with more energy will have a higher temperature than air with less energy. So what we're wondering about Christchurch, New Zealand's air temperature during an El Nino year is that it's going to be cooler during these El Nino years, so that means it's going to have less energy in the air. Today, we are trying to figure out how energy gets into the air. So how does air get energy? So not just about the amount of energy that's in that air, but really how it gets there. So we are going to talk about how we can transfer air, or how energy is transferred, So transferring is moving something from one object or one place to another. So think about if you've ever picked up something and walked across the classroom and set it down, or if you've transferred something from your phone to somebody else's phone or something like that. So when we're looking at energy transfer in air, what we're wanting to know is how does energy get into the air? So if we know the amount of energy in the air determines what the temperature of the air is, how does the air actually get energy? So we are going to investigate that today. We are going to do that by looking at these two claims. So we know that we get energy from the sun, so we are going to use the sun as our energy source today. We are going to look at our first claim. So the first thing that we are going to look and investigate or think about is energy transferred from sun to the air directly? So does it go directly from the sun into the air? Or is energy transferred from the air or from the sun to the surface, either land or water, and then to the air? So we are going to make claims. These are our two claims. We're going to kind of pick one of these claims, which ones we think we're going to agree with. We're going to gather evidence, and then we are going to come up with some reasoning. So when you pick your claim, you're going to make a hypothesis. So if energy is transferred from sun to, you're going to either say air or surface, right? Either claim 1 or claim 2. And then you're going to tell me what you think is going to happen. Do you think that the energy in the air is going to increase? Is the energy in the air going to decrease? Is there not going to be a change in energy? And then you're going to tell me why you think that's going to happen. In your heating experiment lab today, you are going to have a lamp, which is going to represent the energy from the sun. We are going to have some air, which is going to represent the air. And this is going to be the air directly above the surface, just like we talked about in our last lesson with the atmosphere and looking at that air directly above the surface. And then we are going to also have some rocks, which is going to represent the land, so either water or land outside and our surface. So these three things are going to be how we set this up. So if we really look at it, we have one that's going to help us understand claim 1, one that's going to help us test claim 2, and then we have our energy from the sun. So we are going to measure the temperature. That's our data, right? We're going to look at how we can measure temperature. We are going to use a chart that looks like this. So we need to start by gathering our initial temperature, and we are going to measure that temperature prior to turning on the sun or turning on our light. We're going to put that number here and that temperature here for cup 1 and cup 2. So nothing under the surface, and then air and then the surface. Then we're going to measure after 20 minutes. We're going to take our final temperature and we're going to put that number here and here. And then we're going to find the change or the difference. And to do that, we're going to take this number here and we're going to subtract it from this number here, and that's going to be our difference. So let's take a look at this really quick. Again, no air, so that's cup number 1, and then air above the surface, so that's with the rocks, that's going to be cup number 2. Some of the variables that we're going to be testing in this experiment, so we want to know what we're changing and not changing. Our independent variable, the thing we are changing is the heating lamp on or off, right? Are we getting energy from the sun or not? Our dependent variable, the thing that we're measuring, is the temperature itself. So what is the temperature underneath these, in these areas, the air in these areas? And then the thing that we're going to keep the same is how long we're testing it, the temperature that it starts at. So we're going to make sure that we leave these away from the cups so that they don't, or away from the sun, so they don't get warm before we measure them. And then the distance from the lamp. We're not going to move the sun once we start the experiment. So you're going to start by measuring the temperature above the air at the two locations with these cups before you turn on the heating lamp. You're going to take these cups, you're going to move them away from the heating lamp, and then you are going to turn on the heating lamp. Wait 20 minutes. You have a timer on your lab sheet, and then you're going to come back and you're going to measure these one last time, and then you'll take the difference and record all of that data. While you're working, there is a worksheet. There is a storyboard page for you to get started on. You will start by completing numbers 1 through 6. So you should fill in the blanks on these questions, and then draw some pictures to support that. And then once you are done with this, you can put this back in your classroom's drawer, and we will hold on to those to finish the rest of them in the second part of this lesson. Once you are done comparing all of those, then you are going to jump into the simulation and try to simulate this lab in the digital simulation. So remember that we're thinking about these claims. Is energy transferred? How is energy transferred to air? So claim number 1, energy is transferred directly from the sun to the air. And if that claim was correct, then there would be the same temperature as the air above the rocks. So we would have the same temperature here and here. And claim number 2, energy is transferred from the sun to the surface and then to the air. And if that is correct, we're going to notice that there would be some sort of change in temperature. So we'll either have a lower or a higher temperature here when we measure that than over here. So remember that once we get into these, once we get into our data table, we will see that if claim number 1 is correct, then we will have no change here. So this would be 0. If claim number 2 is correct, then we would have a change here, and we would know if there is some sort of energy change. The last thing, we're just going to quickly review our scientific process. So we're going to ask a question. What determines how does air get its energy? We're going to make some observations, which you are going to do in your assignment. You're going to form a hypothesis like we talked about, and then you're going to complete this experiment. And then at the end, we're going to analyze some data, and we're going to reflect in order to have a conclusion. You are going to need your assignment on your Chromebook. You're going to need this paper here, and you're going to follow that procedure in the video, and then complete the storyboard, and then do the simulation. If you have any questions, feel free to check in with me. Send me a message if you need it or anything like that. And remember, today is a great day to learn. Happy learning!